Logarithms, the basics. So if I say, look, let's take x and make it greater than 0. That just means x is positive. B is greater than 0. It's positive, and b cannot be 1. So what's going to happen, I'm about to give you something, and I want to restrain or put constraints on x and b. I want to say x has to be positive, b has to be positive, and also b can't be 1. All right. So then I write down this thing here, y equals, and have this curious log with a little b that's actually subscripted. I want you to notice that if you were to draw a line under the log of x, the b it would go right through the b, right? It underlines log of x, but it goes right through the b. That b is subscripted, and it's written a little smaller, okay? So how do I read this thing? Well, obviously we know that it's y equals, right? You know y equals. We read this as y equals, and then here's sort of the new part, log base b. We read the log with the subscripted b as log base b, and then of x. So y equals log base b of x. This is equivalent to this thing over here. Now this was something we're familiar with, maybe not with b's and y's and x's, but we know how to read that. That's b to the y equals x. That's an exponential, because it's got an exponent, right? B to the y equals x. These two things are equivalent. And the bases are pretty obvious, right? Here's your base, and here's your base. We know that's called a base. We also know then that this is called an exponent. What may be weird and different is that this is also an exponent, okay? So you have your bases b, and you have your exponents represented by y on each one of these, okay? So your logarithmic form is y equals log base b of x, and your exponential form is b to the y equals x. So what happens is when you're working in algebra, you're working with logarithms, and it doesn't even have to be algebra, whatever you're working with logarithms in, you may need to solve for y, b, or x. And depending on the form it's given in, it may be easier to change the form. Like if you may be given a logarithmic form and you may need to change it to the exponential form in order to solve for one of the variables that you need to solve for, or vice versa. You may need to change an exponential to a logarithmic. So that's what I want to focus on right now, is how do we change this? How do I change from one form of a logarithm to the other form? And notice I don't say how do we change from exponential to logarithmic or logarithmic to exponential. I just say how do we change from one to the other, because I'm going to do it the same way. Okay? I'm going to do it the same way whichever direction we're headed, which is glorious. All right? We just need to keep in mind at one direction we're removing the log, and the other direction we're putting the log in, right? Because one of them is a logarithmic and one of them is not. So here I start with the base. If I am changing forms, I start with the base every time. Then I'm going to tell you more about this later, what I mean by move across the equal sign, okay? Move across the equal sign, and then we're going to equal what's left or equal what remains, all right? So I'm going to start with the base. I'm going to move across the equal sign, and I'm going to equal what is left. So if you're changing from logarithmic form to exponential form, the first thing I'm doing is I'm changing from logarithmic. So that means I'm getting rid of the log, right? No more log. No more log. And I start with the base b. So I'm trying to write it as b, right? So then to some power equals something else. So then I move across the equals. So I start with the base and I move across the equals. And the only thing over here is y. That's where this y comes from, okay? So b to the y, and then equal what's left, right? That's what I mean by move across the equal sign, right? Now equal what's left. So equal what's left. The only thing here is x. That's where I get this from. Equal what's left, all right? So then b to the y equals x. I start with the base. B to the y equals x. B to the y equals x, all right? What if I'm going the other direction? What if I want to go from exponential to logarithmic? Well, look, if I begin the logarithmic form, I need to write down what first? Log. Right? I'm changing it to logarithmic. It didn't have a log in it. I've got to introduce log. So if you want to say technically you write that down first, that's fine. But I'm starting with the base. I write log because I know I'm changing the log. And then I say start with the base. That's where that b comes from right there, okay? So then log base b, and then I go across the equals. So b to the what? X. That's where this x comes from. Log base b of x, and then what? Equal what's left. Equal what's left, all right? That's where this equals y comes from. So I say start with the base, across the equals, equal what's left. Okay, it doesn't matter what order it's in either. It could be x equals b to the y. I start with the base no matter what side the base is on, left or right. Okay, and then I start with the base, move across the equals, and then equal what's left every single time. All right, so let's practice transforming or rewriting some of these in a different form. So here, all of these on the screen, all 4 of these are logarithmic. And I want you to rewrite an exponential. Notice I didn't say simplify or verify. I'm going to try to give you all these that are true, not anything that's false. Okay? So here, what do? I start with the base. Here's my base. It's on the right-hand side. Doesn't matter where it's at. Start with it. Start with the base and go across the equals. So 6 to the 3rd power and then equal what's left. Equals 216. Notice I don't have a logarithm there, right? I got rid of the log. I was rewriting as an exponential function, right? So there's no log in an exponential. Or not in this one. So then here, how do I rewrite this one? I start with the base and go across the equals. Now notice this time my base is on the left-hand side. Doesn't matter what side of the equation the base is on. You always start with the base, move across the equals. So this is 12 to the 2nd power and then equals 144, okay? Equals of 144. So 12 squared equals 144. So start with the base, go across the equals what is left or what remains. So I'm going to do the same thing here. 2 to the what power? 2 to the 4th, right? Start with the base. 2 to the 4th and then equal what's left? Equals 16. And then finally this last one here, start with the base, which is what? 3. 3 to the what power? 3 to the 5th equals what? 243. All right, so that was practice writing from a logarithm and changing it into an exponential form. What if I'm given exponential form and I want to change it into a logarithm? Well, I start with the base. I go across the equals and equal what's left. The first thing I have to do, though, is write down the word log and then the base. Log base 5 of what? 125. Right, I move across the equals. Equal what's left? 3. So log base 5 of 125 equals 3. I want you to notice something how I wrote this. This is something that gets students every semester I teach this. I'm in my 22nd year. I've taught fall, spring, and summer. Even the 5 years I was an administrator, probably every single year. So we're getting in, 64, 65 times I've done this now. And this is something that gets students. Notice this line right here. This, and this are all on the same line. But where's the 5? It's lower. It's a subscript. Okay? So I want you to note that. Everything's on the same level except the 5. I get all kind of variations of the 125 looking like a power, the 125 equals 3 looking like a power with the 5 on the same level as the log. No, the log, the 125, and the 3 are all on the same line, and the 5 is the only thing that's not in line with those. It's subscripted. It's lowered, okay? So let's keep looking at these. What about 8 squared equals 64? Well, again, I'm changing to a logarithm. I start with the base. So log base 8 of 64, when I move across the equals, that's where I get the of 64, and then equal what's left. Equals, the thing left is 2. And when I say what's left, I've already taken care of the 8 and the 64. That's why the 2 is what's left, right? That's why the 2 is what's left, or what remains. All right, so let's look at 343 equals 7 to the 3rd. And again, it doesn't matter which side our base is on. Here our base is on the left. Here our base is on the right. It doesn't matter. We start with the base. So again, we're changing the logarithm. So write the log and then start with the base and go across the equals. Log base 7 of 343 and then equals what? Equals 3. And then 1,024 equals 2 to the 10th power. Again, we write down the word log because we're changing the logarithms. And then we start with the base and we go to the other side. So log base 2 of 1,024 equals what? Equals what's left, which is equals 10. Okay? Log base 2 of 1,024 equals 10. I'm going to fix this just a little bit here. I don't like how high my 124 looks compared to my log. All right. So then if I were to draw a line across here, this is all on the same level, and the 2 is obviously lower, right? It's obviously lower there. So notice that even when I wrote it on the screen here, I went back and looked at it and said, you know, I don't quite like that. So let me encourage you. The whole reason you're watching this video is why? Because you probably have a test on this in a class. You're not just sitting around watching logarithm videos for fun. Who does that? Maybe another math teacher or something. I don't know. I mean, you're watching this because you're in an algebra class somewhere, algebra 2, college algebra, intermediate, something that's making you do these logarithms, and they're giving you fits, and you went to YouTube and said, hey, I need some help. And I found this crazy guy. Okay? So logarithms, the basics. Let's talk about the common logarithm. The common logarithm is y equals log x. Now notice what's missing here. There is nothing written there. There is no base, right? There is no base. That's because the base is understood to be 10. So in math, almost everything is understood to be 1, and then all of a sudden you get the square roots and there's an understood 2, right? That index, the root is a square root, is understood 2. We're not talking about roots here, but I'm just saying that's an understood 2. And now all of a sudden we have an understood 10 with logarithms. All right? You have to keep a note in your phone, right, about all these different understoods in math. All right. So then the natural logarithm. So there's two major logarithm, categories: common and natural. And on any scientific calculator or above, these two exist. Now, on some of the newfangled graphing calculators and all that stuff, there are ways you can enter the base in, so you won't need some of the stuff we're going to do here. But I want to show you these things because many of the students I teach have the TI-30X2S, for instance, okay? And currently that's what they can use where I am. And that one only has the log, and then here, the natural logarithm, the ln. That's not 1n. It's not ln. We're not mowing the lawn, okay? This is not ln. I know a lot of people say ln. I don't understand why they would say that. It's ln. It's un. All right, it's the natural log, and I don't know why we use ln for natural log. I don't know my math history well enough to know why it's not nl. But anyway, ln. Y equals ln of x. Again, notice there's no base, but we don't even write the word log. We write ln, okay? The natural log, that's because the understood base is e, and you're like, what on earth is e? What on earth is e? E is the value 2.71828, and it goes on forever and doesn't ever keep repeating. It actually goes 2.71828, and then it goes 1828 again, but then it changes to something else. All right, so it doesn't repeat. You can't put the line over it. It's just E equals that. All right, and there's a button on your calculator for E as well too. So what if we wanted to change these common logarithms, right? Here's a common logarithm, and then what if we wanted to change a natural log? How will we do that? Well, what do we do to rewrite this? We get rid of the log and we start with the what? We start with the base. We go from the base to the other side. Well, what's the understood base here? 10, and that's why I wanted to do one of these. The understood base here is 10. You don't have to write the 10 down. You just need to know, hey, the 10 is there. In fact, when you write logs, you don't write log base 10. You just write log if the base is 10. If the base is any other number besides 10, you put a number there, base. If it's e, then you don't write log, you write ln, and you don't write a base again. So here, 10 to the third, and then equal what's left. Equals what? 1,000. Okay? 10 to the third equals 1,000. And then here, we're getting rid of the ln. We're going to start with the base equals this. So if you wanted to think about this over to the side, if you wanted to think about this, you could say log base e equals 5. Now, you really would never do that. But I'm saying as far as rewriting, right, that's how we're thinking about this, okay? So, but you just remember ln is base e, so we're going to say e to the 5th power, and then equal what's left equals x. So e to the 5th power equals x. And what if we wanted to go the other direction now? What if we wanted to rewrite this as a logarithm? Well, here, I always change it to log, right? Change it to log. Log base what? Log base e of 162 equals what's left, which is what? Y. But wait a minute. I don't want to leave that there. Right? If I'm just rewriting it, that's how I rewrite a logarithm, right? That's how I teach, that's how I do it. Log base e, but then I say, wait a minute, log base e, I don't leave it log base e. So this one has one little extra step that I'm going to do if you don't recognize it from the beginning. If it's log base e, I'm probably just going to go straight to, wait a minute, that's ln. Okay? But if you follow the steps exactly how we've done them, this is what you end up with, and then you say, wait a minute, go to the next step here. Don't leave it as log base e. I'm quite positive your teacher's not going to want you to write log base e. They're going to want you to write ln. All right, so 10 to the 5th equals 100,000 here. So again, we're going to change it to log, and we're going to start with the base, right? So if I start to write 10 and go, wait a minute, I don't need to write 10 down. Log of what? 100,000 equals what's left, which is 5. If you write the 10 there, just do the same thing we did over here. If you write the 10 here, write it down again without that. Right? Write it down again without that. So log of 100,000 equals 5. And I don't like my spacing here. This is, you don't know this where you're at, but this is low on my board. Okay? So let me just fix this whole word log. I don't like it. I want that all to be on the same line because it is. All right, log of 100,000 equals 5. All right, so I hope this helps you out with the basics of logarithms, rewriting from one form to the other. All right, and the common log and the natural log.